Alright guys, this lesson is on the mean value theorem for integrals. If you remember, there was a mean value theorem for derivatives, and what the mean value theorem for derivatives said was that if you had an interval a to b, then there is a point c that's between a and b, such that the slope of the secant line between a and b is equivalent to the derivative at that point c. That's what the mean value theorem for derivatives said. Now, the mean value theorem for integrals says that the definite integral from a to b of f of x dx is equivalent to b minus a times f of c. Now, that's what the actual theorem says, but let me break it down to you in a more geometrical aspect. Remember, the definite integral represents the area. So this half represents the area under the curve from the interval a to b. And what it's saying is that the area under the whole curve is equivalent to the width of a rectangle that's on that interval, see, b minus a, because see, it's on the interval a to b, so b minus a would be the width of that interval, or the width of the rectangle, times the height of a rectangle, which is f of c. And so what this is saying is that on any interval, there exists some rectangle such that the area of that rectangle is equivalent to the area under the curve. Let me draw you a picture, and that might help as well. For example, let's say that you had this random function and that you wanted to calculate the area under this curve. So you're wanting to find the area up under this curve. What the mean value theorem says is that there exists some rectangle that has the width of the interval, but there is some height to this rectangle such that the area on that rectangle is equivalent to the area under the curve. That's what the mean value theorem for integrals represents. Now, we're going to use this mean value theorem, do some manipulation to it, and we're going to come up with a formula for the average value. All right, so I'm not going to show you how to derive it, but you basically use the mean value theorem to derive the formula for the average value. Now, here's the formula for the average value of a function. If you have an interval a to b, the way that you find the average value is you take 1 over b minus a and you times it by the definite integral of the function. Now, what the average value of a function represents, and it can also be referred to as the mean value, it describes the average height of a graph. So if you can imagine a graph, a function, it goes up, it goes down, it goes up, it goes down. What the average value, the mean value, tells you is what the average height of that function would be. So like even though it goes really, really up or it goes really, really low, it's the mean value theorem or the average value of a function is going to tell you what that average height is going to be. So for the most part, we're going to be using this formula. Okay, so let's jump right into it and go ahead and look at an example. So for this one, it says find the average value of f of x is equal to sine of x on the interval 0 to pi. All right, so right off the bat, it says average value. So I know I'm going to go ahead and write down my formula, 1 over b minus a times the integral from a to b of f of x dx. All right, in this case, my interval is 0 to pi. So 0 would be my a, and pi would be my b. So I'm going to plug that into my formula. So I'm going to have 1 over pi minus 0 times the integral from 0 to pi of my function, which in this case is sine of x dx. All right, I know that pi minus 0 is just pi, so I'm just going to write that as pi. And I'm going to tackle this that's outside the integral at the very last. What I want to do now is I want to focus on the definite integral of sine of x dx from 0 to pi. Now remember, use the fundamental theorem of calculus here. The way that we can evaluate a definite integral is by first finding its antiderivative. Well, the antiderivative of sine of x would be negative cosine of x. And now that we got my antiderivative, I'm going to evaluate this antiderivative using the upper limit and the lower limit. So I'm going to have negative cosine of pi, and then remember, you're going to change your sign, so minus a negative, so that's just going to change to a plus cosine of 0. And so that's what's inside of my bracket. And so now let's just evaluate this. Cosine of pi is negative 1, so negative cosine of pi will just be 1. Cosine of 0 is 1. And so I get 1 plus 1 is 2, and I get 2 over pi is my final answer. And what that 2 over pi represents, guys, is that means that the average height of this function on the interval from 0 to pi is equivalent to 2 over pi, which I don't have a calculator right at the moment, but it would be roughly 2 divided by 3.14, whatever that value might be.